Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. My 2016 question on sequence and series from Leaving Cert higher level. At the first stage of a pattern, a point moves 4 units from the origin in the positive direction along the x-axis. For the second stage, it turns left and moves 2 units parallel to the y-axis. For the third stage, it turns left and moves 1 unit parallel to the x-axis. At each stage after the first one, the point turns left and moves half the distance of the previous stage as shown. How many stages has the point completed when the total distance it has travelled along its path is 7.9375 units? Okay, so there's a couple of very important things you have to know about sequence and series to get you through, okay? You have to be able to tell the difference between an arithmetic sequence and a geometric sequence. So in an arithmetic sequence, you're adding on the same amount or subtracting the same amount every time. Be careful though, that could be the first difference, or you can have second difference and so on and so forth. Geometric sequence, you're multiplying or dividing by a ratio every time. Okay, so that's the first thing. You've got to be able to tell the difference between the sequences. 2 standard questions they ask on arithmetic is to come up with the formula for the nth term, and that's you coming up with the formula for Tn. They could also ask you to come up with the formula for the sum of the first n terms, which is the Sn formula. In geometric sequences and series, then, they could also ask you to come up with the formula for the nth term. It has its own Tn formula. It could also ask you to come up with a formula for Sn. Now you see there's 2 Sn or S formulas on your course. The first one is to come up with the sum of the first n terms. And the second one is sum to infinity. So it's the infinity symbol like that, okay? Sum to infinity. So you're looking out for that word infinity if it's a geometric sequence, and then you use this one. A is the first term in both. The common difference in an arithmetic sequence is D. The common ratio in a geometric is OR. Sum to infinity only works if OR, that common ratio, is less than 1. Okay, so all there on page 22 of your log tables. Okay, so that's the sequences. When I look up here and I see that it's half the distance each time, well, that's a bit of like a divide by 2. So this is naturally a geometric sequence. Okay, and then I could use formulas, or I could simply, it doesn't always have to be fancy maths. Okay, you can see in the first stage, I travel a distance of 4. In the second stage, I travel a distance of 2. In the third stage, I travel a distance of 1. Then I travel a distance of a half. So 4 and 2 is 6. 6 and 1 is 7. I'm just trying to keep a running total here. That's 7.5. Half of a half is a quarter. So that's 0.25. And if I add that on, that's 7.75. Half of a quarter is an eighth, and an eighth in decimal is 0.125. And if I add on 0.125 here, and then a 16th, and so on and so forth. And eventually you will get to 7.9375. Okay, and that's a perfectly acceptable way of doing maths. Okay, and you can figure out how far have you gone when you are at 7.9375. 1, 2, 3, 4, 5, 6, 7 terms. I don't know what 1/16 is. It's 0.0625. And if I add that on to 7.875, I do indeed get 7.9375, okay? So that's 1, 2, 3, 4, 5, 6, 7, okay? So 7 stages, or n is equal to 7, okay? So even if you knew nothing about sequences, but you carefully read the question, you figured out the pattern, and a lot of people's brains work with patterns, and a lot of people are good at maths because they see patterns in maths. You could have got full marks on this particular question. Okay, so that is one perfectly acceptable way of doing it. Or you could use your knowledge of sequence and series, okay? So in any sequence and series question, you have to write out the sequence. So my first stage is I've moved 4. My second term, I've moved 2. My third term, 1. My fourth term, a half, ... okay? And you only ever need the first couple of terms. Okay, we've established it's a geometric sequence. So therefore, my first term is 4, okay? And my common ratio, well, I'm dividing by half every time. Okay, and your SN formula then, so it's this one that I'm taking from the log tables, A times 1 minus r to the power of n over 1 minus r. And you sub in your values. So it's 4 times 1 minus a half to the power of n over 1 minus a half, okay? And we want to know when is that equal to 7.9375. Okay, I didn't give myself near enough space, so I'm going to move up the top, okay? So I am going to do this. 4 times 1 minus a half to the power of n is equal to 7.9375 times 1 minus a half. Okay, basically I just brought that 1 minus r up. Okay, so let me tidy up that. So it's 4 times 1 minus a half to the power of n is equal to 7.9375 multiplied by a half. So I got 3.96875. Okay, I'm then going to divide both sides by 4. So I'm trying to get at that n that's in it. Divided by 4. 0.9921875. Okay, of course you could leave it as a fraction, 127 over 128. I'm then going to bring this 1 over, or subtract 1 from both sides. So I'll get a minus a half n being equal to, so let me subtract 1 from that, minus 1 over 128. Change the signs all the way across. Okay, and then when what you need is in the power, you need to use logs. Okay, that's where logs comes into play. So logs, the two rules for solving when something is in the power is this one here, which we call the switch, or it's either of these two, depending on whether it's a power or a log. Okay, both of these will give you the what's in the power. Okay, so I have in my question a half to the power of n. Okay, so I have my a is a half to the power of n. Okay, so that's that piece here. So if I match this number here to the base of my log, so if I go log to the base a half, okay, just make that a small bit clearer. If I go log to the base a half, okay, and I can see that because you see the way this is the base number, you match the base number on the log to the base number of your power, okay? And what ends up happening is the a and the log a cancels, okay? So in my one, what's going to happen is the half and the log half will cancel, and I'm left with just what's in the power, which is n, okay? And I can't remember what that was equal to, 1 over 128. But what I do to one side, which is that log to the base of half, I have to do to the other side. Okay, so that's how you use this rule here. This is the opposite rule. If you need to get at the x, for example, you raise everything to the same base number that's in your log. And if anyone's struggling with logs, let me know and we can do a class on logs. Okay, and you can see that's just a number that you put into the formula. Okay, if you prefer the switch, we had a half to the power of n being equal to 1 over 128. Okay, so what I do for the switch is my a, in this case, is a half, so I put my a there. My x is the power, and what it's equal to is y. Okay, and then you rewrite it over here as a log, and that'll allow you get at the power. So I can rewrite this as log. My a is a half, so that goes here. My y is here, and it's equal to my x, which is n. So you can see it's just two different ways of working with logs. Okay, and it doesn't matter, as you can see, which one you use, it's just whichever one your brain prefers. Okay, I tend to use this one for no reason at all, in that it's just easy for me to see the two of them cancelling, because I can see the half and the log half cancelling, and just what I do to one side I do to the other. So for me, that's a really easy one to use, but it's by no means better. When you're putting the log into the calculator though, you cannot use the button that says just LOG, the one that's under my ABS button, or it's under x to the minus 1 if you're using the calculator from 2 years ago. Okay, on the ClassWiz calculator, it's under ABS. Well, both of them are above cos. Okay, you can't use that log button because on your calculator, that log button is logged to the base 10. Okay, base 10 is a very common log number, so they've reserved a button for that. Instead, you have to use the button which allows you to put in your own base number, which is directly under the on button. Do you see it's got log? So you're looking for the button that has log and a colored in box and a box. Okay, this one allows you to put in your own base. Okay, so that's the button you're looking for. So hit that button, put in the half as your base, go over and then put in the 1 over 128 in the other bracket, and you should be able to get 7. Okay, so a great old question in a way, because if you use the formula, because it also tested your knowledge of logs. Okay, but like I said, there was nothing wrong with the first way we did it, where we just added up all the different lengths. Okay, part 2 then of that question says, find the maximum distance the point can move along its path if it continues in this pattern indefinitely. Okay, that's the word you're looking for if it's a geometric sequence, and you then instantly know it's the sum to infinity formula. Okay, which is this one here, a over 1 minus r. If you remember, a was our first term, or was our common ratio. So you put 4 over 1 minus a half, which is 4 over a half, which is 8. Okay, so why does sum to infinity be something like 8? Well, it's because we're halving all these fractions. If you remember what we had here, we had a quarter, we had an eighth, we had a 16th, and 1 over 32, the fractions are starting to get really, really small. So they're having very little effect on what we add on to n is equal to 7, the sum of. Okay. So that's why in an infinite, if you keep going around like such, you will get your sum to infinity, your distance, to be 8. The fractions are going to get so small that they're going to have a negligible effect on the length of that line. Okay, so 8 is the sum to infinity. So make sure you know that formula and make sure you look out for that word indefinitely or sum to infinity, or if it continues forever, it'll be one of those words. Okay, complete the second row of the table below, showing the changes to the x coordinate the first 9 times the point moves to a new position. Hence or otherwise, find the x coordinate and the y coordinate of the final position that the point is approaching if it continues indefinitely in this pattern. Okay, so I have all my stages, change in x, change in y. Okay, so for the first pattern, I moved along the x-axis by 4. So this is the plus side, your numbers are getting bigger. If I go this direction, it's the minus direction, so your numbers are getting smaller. Similar, minus direction in y, plus direction in y. Okay, so I move along here 4. I don't change it all in y, I don't go up or down. For the second stage, you move +2 up in the y direction, but of course you don't move at all in the x direction. Okay, so he's a +2. The third one, you're coming 1, 2, you're coming down on yourself. So that's a -1 in my y. And I don't change in my x, okay? So 0, 0, 0, you can see now that you're only ever going to change one coordinate at a time. Okay, and then, yeah, where was I? That was stage 3, stage 4. So 1, 2, 3, 1, 2. Oh, I went the wrong way. My apologies. That was my -1 that I changed in my x. Yeah. And 0 in my y. So on stage 4, then, I would have only changed by -0.5 in my y and nothing in my x. Okay, and then I go positive again and positive. So it's 2 positives, 2 negatives, 2 positives, and then it'll be 2 negatives again. Okay, so -0.5, so he would be +1/4, and he would be +1/8. He would be -1/16, -1/32, +1/64. Okay. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.